just hashes for bricks, because there's a pattern here, one on top of the other, and I bet we can solve this in any number of ways. Well, let me switch back over to VS Code here, and let me propose that we create a program called Mario.py using code in the terminal window. And then up here, let me start by implementing that same picture as simply as I can, printing out just literally the hash, and then the hash, and then a third final hash. This is going to be a very textual approximation of it, but I think if I run Python Mario.py, I've got a very simple version of that same column of bricks, so to speak. But you can imagine that certainly in a game where maybe the columns get higher or lower, it would be nice to write code that's actually a little more dynamic than that and doesn't just use print, 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 which is literally copy and paste, it would seem. So let me at least adopt some of today's lessons learned and instead do something like this. For underscore in range of 3, let's now print out just one of these at a time. But the fact that I've now used a 3 to range means if I want to change it to something bigger or smaller, I change it in one place, not in 3 or more places. And this code too, of course, if I got it right, is just going to print out the exact same thing. So we're iterating here. But let's see if we can't now integrate our discussion of writing functions of our own to begin writing something a little more dynamic and solving more complicated problems ultimately. One of the nice things about functions is that they allow us to not just write code that we can use and reuse, they allow us to create abstractions, if you will. An abstraction is a simplification of a potentially more complicated idea. And we've seen this a few times over the course of the weeks. For instance, we had a function called hello, which granted didn't do all that much. It just printed hello, but it allowed me to think about the function as exactly what it does. Not generically printing something, but literally saying hello. I've been able to get a number using something similar by defining my own function like getNumber. Well, let me go ahead and, for instance, assume for the moment that I've had the forethought to, in my function main, use a function called printColumn. That seems as good a name as any to use a function that prints a column of bricks. Well, how can I go about now implementing this abstraction, this simple idea, printColumn, with actual code? Well, we've seen before with def, we can do just that. Let me define a function called printColumn. Let me accept as its input, generically speaking, a parameter called height. I could call it n or h, but I'll be a little more explicit now with height, just so I remind myself what it's doing. And now I think I can just borrow some of that same code from before. For underscore in range of height, go ahead and print out a single hash. And then at the end of this whole program, let's just call main. So I've kind of complicated the code. It doesn't do anything more just yet, but it's setting me up for solving what I think are going to be more sophisticated problems. If I run Python of Mario.py, we're back where we began. But I now have a function, an abstraction, printColumn, that's going to allow me to think about printing some chunk of the world of Mario at a time. And I can do this in different ways too. Notice that if I really want, I could do something like this. I could re-implement now printColumn in different ways, especially if I'm using printColumn all over my code, or maybe still a colleague of mine, a friend, someone else on the internet is using my printColumn function. What's also nice about functions you've written is you can change the underlying implementation details of them, but so long as you don't change the name of the function or its parameters or what it returns, if anything, no one else knows the difference. You can change the internal implementation as much as you want if you want to improve it or make fixes over time. So for instance, another way we could implement printColumn, recall, would be something like this. A bit clever with one hash and then a new line. And then maybe we could do multiplication of strings and then end this line with quote unquote. Again, it's OK if you're not comfortable with this syntax. This was a more clever approach we saw in the past. But if I run Python of Mario.py here, I'll still see a column of 3. But what's important here is that main does not need to know that the underlying implementation of printColumn has changed. Well, let's transition to a different dimension, if you will. And rather than print out just these vertical bricks, let's fast forward in the game to this part of the world here. At some part, Mario encounters these bricks in the sky that if he jumps up underneath, they become coins. And so he gains to his score. But let's go ahead and focus only on those coins. And let me propose that we print out, just these 4 question marks here. And let me go back to VS Code here. And let me propose that within VS Code here, just like before, we try to abstract this away. So let me go ahead and get rid of this version, because we're now going horizontal instead of vertical with our output. And let me just say, well, print row 4 times. Let me just abstract away the problem at hand. I don't know yet how I'm going to print those 4 question marks, but let's call it print row 4, and I'll assume I'll now solve this problem. Let's now go down that rabbit hole of solving the problem. Define a function called print row. It's going to take a width instead of a height, because it's horizontal instead of vertical. And how can I do this? Well, now we have an opportunity to do string multiplication even more elegantly. I can say quote unquote question mark times width. And this is a very pretty Pythonic way of printing what could otherwise be a loop, and that's fine. But this is going to go ahead and print those question marks for me. Let's do python of mario.py, enter, and now I've got 4 question marks. It's not nearly as pretty as the more graphical version, but it is at least a building block toward having now a reusable function like print row. And why am I doing all this? Like, why are we over-engineering the solution to these problems by having print column and print row? Well, it's a useful problem-solving technique as soon as your world does not look one-dimensional like this, or with the column version. But what about this? Later in Super Mario Brothers, does Mario have to jump down into this world where there's a lot of these underworld barriers? And this one here, for instance, looks like a square. It's 2-dimensional. There's a height and a width to it. And that is to say, there's a bunch of different ways we could implement this thing if maybe for discussion it's like a 3x3 grid, a 3x3 square of sorts. Well, how can we go about solving this here problem? Well, let me propose we come back to VS Code, and let me propose that we think about this in a couple of different ways. I could do this like this. If I know where I'm going, you know, maybe I'm a seasoned programmer, let me go ahead and do this. Let me print out a square, the width and the height of which is 3. That's an abstraction. I'm just taking for granted for a moment that there is already a function called print square that's going to be width 3 and height 3 as well. But someone's got to implement this. And at the moment, there's only me at the keyboard, so let's go ahead and implement that square. Let me go ahead and define a function called print square that takes in a specific size, both for height and for width. And here's where we have an opportunity to use some of those loops. And we can use those loops in a way we haven't yet. If I want to print out all of these rows, but also all of these columns, I now have to think not just cyclically, like a loop allows, but I need to think 2-dimensionally. And if you're familiar with like an old school typewriter or even a printer nowadays, it generally prints from top to bottom. So even if you have multiple columns, you print out one line at a time. And while you're on that line, the printer or the typewriter prints from left to right. And that's kind of the mental model to have with your black and white terminal window. All of the output for every example thus far starts at the top and goes down to the bottom, from top to bottom, left to right. So we have to generate our output, our square, in that same way. So let me propose that we do this. Let me propose that we know we need to iterate this many times, 3 or more generally size. So let me do this. For I in the range of size, what do I need to do 3 times? Well, I want to print out what? 1, 2, 3 rows of bricks. But within each row of bricks, what do I want to print? 1, 2, 3 bricks specifically. So if we go back to our diagram here, and I stipulate that it's indeed meant to be a 3x3 square, 3 wide and 3 tall, what do I want to do to print the first row? I want to print brick, 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 brick. What do I want to print on the second row? Brick, brick, brick. And the third row, brick, brick, brick. So I'm doing 3 things 3 times. There's a lot of printing that must happen. So let me go back to my code here, and let me propose now that we think of this outer loop that I've just started as representing each of our rows. For I in range of size is going to ensure, no matter what I do next, that I can print out 1, 2, 3 rows, or more generally, size, where size could be 3, but it could be smaller or larger. What do I want to do on each of the rows? Well, just like an old school typewriter or printer, on each row, I want to print out brick, 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 brick. Well, that sounds like a cycle, some kind of loop. So maybe I can have inside of one loop another loop. I don't want to use I again because I don't want to use the same variable and mess up my counting. So I'm going to, by convention, use j. Very common to use I and then j, maybe k. But after that, you shouldn't keep nesting inside of each other. Let me go ahead and say for j in range of size 2, because it's a square, and then each of these rows, let me print out a single hash, but no new line. But after each row, let me print only a new line. So there's a lot going on here, especially if you've never touched Python, let alone loops. But notice what I've done here too, and I'll add some comments for clarity. For each row in square, for each brick in row, print brick. And here is where comments, and more generally pseudocode, can really help explain to yourself and to others what your lines of code are doing. On line 8, I'm iterating from I equals 0 on up to size, so 0, 1, 2. On line 11, I'm doing the exact same thing but using j from 0, 1, 2. But that's good because I represents now each of my rows. And while I'm on each of those rows inside of this outer loop, I'm going to do brick, brick, brick. 1, 2, 3, 1, 2, 3, 1, 2, 3. But I don't want my cursor to keep moving to the next line while I'm on a row. So I'm just overriding that line ending. But let me ask a question of the group now. Why on line 16 do I have a print here all by itself? Why do I have a print all by itself? Notice that it's below the inner loop, but inside of the outer loop, so to speak. What is that loop on line 16 doing ultimately?
Every time you finish a line, you have to add a new line at the end of it. So it prints a new line.
Perfect. I don't want a new line after every brick. I only want to do that at the end of the row. And that's why my comments now are perhaps enlightening. Notice that this loop here is just iterating for each brick in the row. Once I'm done with that inner loop, so to speak, once I'm done with these highlighted lines here, to Evelyn's point, I need to print out one blank new line. And we've not done this before, but when you call print with no arguments, all you get is that automatic line ending, the \n, where the cursor moves to the next line. So if I now go back to my terminal window and run mario.py, I think I should get a 3 by 3 square. And it doesn't quite look like a square on my screen because these hashes are a little taller than they are wide, but it is in fact 3 by 3. But let me propose, as we've always done here, how we might tighten up this code further. Just for clarity's sake, let me get rid of my comments for a moment, just so we can see how many lines of code we have total. And let me propose that we maybe do this. Let me propose that, you know what, this inner loop, especially if you're having trouble wrapping your mind around one loop inside of another loop, you don't strictly need it. What if we do this trick again? What if we print out inside of the outer and only loop each of those hashes times the number of times we want them? Right? We draw inspiration from an earlier approach, and we run Python now of mario.py, same result, but now print square is really nice and compact. It has one explicit loop, and it's still printing out using string multiplication all of the hashes at once on that row. If you like abstraction and you'd like to wrap your mind more around what the code is doing, well, let's do this. If you're not quite clear on what's going on, let's propose that you implement a function called print row, passing in size. And let me propose that this print row function, it simply take in that width and print out the individual hash times that many times. In other words, here's an opportunity for abstraction, whereby, well, what does it mean to print a row? Well, when you're implementing print square, I don't really care what it means to print a row. I just need to know that someone's taking care of printing the row. You can kind of pass the buck to another function altogether. And how does print row work? Well, it could use a for loop. It could use this string multiplication trick. This is a way to take a larger program, and this is probably the most complicated one we've looked at thus far, and to decompose it into these smaller components that, once assembled, achieve your final idea. Seeing no questions, that's the end of our look at loops in Python, this ability to do things cyclically again and again. And when we combine those with conditionals, this ability to ask and answer questions and combine them with our functions and variables, we really now have most of the building blocks we need to solve much larger, much more interesting, much more personal questions. So in the weeks to come, we'll start to see exactly what could go wrong, though, when we do so. But we'll introduce you to all the more tools via which you can troubleshoot those same problems. All right, this is CS50's Introduction to Programming with Python. My name is David Malan, and this is our week on exceptions. Exceptions in Python, as well as in other programming languages, refer to problems in your code. Indeed, when something is exceptional in your program, it actually doesn't mean it's a good thing. It means something has gone wrong that ideally you will somehow solve. So what are some of the things that can go wrong? So I'm going to go ahead and open up VS Code on my computer here. And in the terminal window, I'm going to go ahead and run code of hello.py. That's going to, of course, open up a brand new tab for me, hello.py, in which I can write my code. And let me go ahead and write some very simple code just to say hello to the world. Let's go ahead and say print, quote, hello, comma, world. And then let me go ahead and I'm forgetting to close that quote. So a mistake that you yourself might have already made or might surely in the future make. And it's a little subtle because you might not necessarily notice that you've just missed that one character. Well, let me go ahead and somewhat optimistically go down to my terminal window now and run python of hello.py and hit enter. And that's the first of my errors. My gosh, I've only written one line of code, and I seem to have more lines of errors on the screen. But the salient point is this bottommost thing here. Notice where it says syntax error. A syntax error is a problem with the code that you have typed, your syntax. Just like English and other human languages have syntax associated with them, so does my code. And it's not quite correct. Something is awry. I didn't follow the instructions properly. And it does elaborate for me. Unterminated string literal. Now that's a bit arcane. That is a bit of a confusing error message. But unterminated would generally mean that I started something but didn't stop it. I didn't terminate it. String, of course, is a sequence of text like we discussed before, or str in Python. And literal generally refers to something that you literally typed. It's not a variable. It's something like quote unquote, or just quote, hello world. So the fix here, of course, is going to be to go ahead and terminate that string and actually close the quote. And if I now go back down into my terminal window and rerun python of hello.py, now I'm saying hello to the world. So the catch with syntax errors here is that syntax errors are entirely on you to solve. A syntax error is a problem that you've got to go back into your code and fix from the get-go. You can't just kind of hope that it's going to resolve itself or expect that other parts of your code will catch it for you. Syntax errors just must be fixed. But there's a lot of other types of errors in Python that might be described as runtime errors that happen while your code is running. And it's really up to you to write some additional code defensively to detect when those errors happen, because you don't necessarily know, for instance, what input humans are going to type into your program. And so you better be ready defensively to accommodate things that they type or even mistype. So for instance, let's go back over here to VS Code, and let me propose that we take a look at a new file altogether. I'm going to close hello.py, and I'm going to write code of, say, number.py. So let's play around with some numbers in Python. And the first thing I'm going to go ahead here and do with number.py after opening this new tab is I think I'm going to go ahead and type up a relatively simple program that maybe prompts the user for an integer like x and then just prints out what x is. So we're going to start super simple. But again, in starting simple, we'll be able to really see where I've done something wrong. Well, here we go. I'm going to go ahead and say a variable called x is going to get assigned the value of the return value of input, quote unquote, what's x question mark. And I'm going to include a space to move the cursor over a little bit. And then ultimately, I'm going to go ahead and, oh, wait a minute. If I'm wanting to get an int from the user, recall that I need to do something proactively. I need to actually convert that input to an integer using the int function in Python. So now I'm passing the return value of input as the argument to int, and that will store in x ultimately an integer, not a string that looks like an integer. All right, let me go ahead now and just quite simply print out what this is. I'm going to go ahead and print out quote unquote, x is x. But I don't want to literally say x is x. I want to plug in the value of x. So maybe the easiest way to do that is to surround it with curly braces. And then if I'm using these curly braces and I want Python to interpolate the value of that variable, that is, substitute what x actually is in between those curly braces, recall that I need to use a format string or an f string by prefixing this whole thing with an f. Now that I've done that, let's go ahead and see what happens. I'm going to go ahead in my terminal window and run python of number.py. I hit enter, and so far so good. All is well. I'm being prompted for x. Let me go ahead and type in a number like 50. All right, that seems to work. Program seems to be correct. Or is it? What could go wrong in this program, even though nothing did just go wrong? But if I run it and run it and run it again, during the running of my program, what could still go wrong, especially if I'm not the human interacting with it, but some other human instead? Any volunteers here for this one? What could go wrong, and in what way is this program not really correct, even though at first glance it seems so?
What is an interpreter? So, when we code in a integrated IDE, we can't code in an interpreter.
So I'm not calling an integer. I'm still having trouble hearing you, but what I think I heard is that if what the user types in is not, in fact, an integer, I can't just blindly convert it to an int. If I'm not putting too many words into your mouth, I think what I should perhaps do here is be a little defensive, and let me see if I can't simulate exactly the problem that could go wrong here. Let me go ahead and run, again, python of number.py. Let me try another number. In fact, when testing your code, generally it's a good idea to test corner cases, maybe numbers that aren't quite as plain as 50 or 49 or 51. Let's choose some numbers that might be a little more interesting, if only mathematically, like 0. All right, 0 seems to work. My code still prints out that x is 0. What might be another corner case to consider? Well, let me go ahead and try a negative number. That, too, is pretty different in spirit from 50. Negative 1? OK, that works, too. Well, let me try it one more time. I've tried positive numbers, negative numbers, 0. Let me try something like a cat. So literally, C-A-T, typing in a string that doesn't even look like a number. And yet, let's see now what happens when I hit enter. All right. We'll see now we've got another kind of error. It's not a syntax error because I didn't make a typographical mistake. I didn't forget some piece of syntax. I actually now have an error with one of my values. And it's a value I didn't even anticipate. The human, me in this case, typed it in long after I wrote the code. So what does this refer to? A value error. Well, let's see what the explanation is. Invalid literal for int with base 10, quote unquote, cat. Now, this too is a bit of a mouthful. And unfortunately, in Python and a lot of programming languages, the error messages are written for pretty comfortable programmers. And of course, when you're learning programming for the first time, you might not be so comfortable with the programming language, let alone the error messages. But let's see if we can't glean some insight. So invalid literal. Well, again, a literal is just something that's been typed in, it would seem. For int, what is int exactly? Well, int is the function I'm using to convert the user's input to a corresponding integer. Base 10, that refers to the decimal system, which is the default that Python's using. And it looks like, at the end of the day, what Python really doesn't like is that I passed cat, quote unquote, to the int function. So how do I go about actually fixing this problem? Well, I could just add instructions in my program. Maybe I could add a line of print telling the user more explicitly, be sure to type an integer. Or please don't type cat. Please don't type strings. Of course, the user might still not oblige. They might not be reading the instructions. So that, too, is probably not an effective strategy. What we really want to do is write our code with error handling in mind. We want to write lines of code that not only accomplish the problems we care about, but that also handle errors that might unexpectedly happen. And in general, when programming defensively, assume that the users aren't going to be paying attention, or worse, they're malicious. They're trying to crash your program, so we want to handle as many errors as we can. Now, how do we go about doing that in Python? Well, it turns out whether you want to catch a value error or other types of errors as well, though not syntax error, Python actually has this keyword called try. And it's sort of aptly named. If you want to try to do something in Python, you can literally use this keyword, and you can check whether or not something exceptional, something erroneous has happened. So using both try and this other keyword except, can I go and try to do something, except if something goes wrong, I can do something else instead. So let's consider, how can I go about trying to convert the user's input to an int, except if something goes wrong. Well, let me go back to my code here. And let me propose that I now modify this example as follows. Let me go ahead and above my first line of code, I literally write try and a colon, telling Python, try to do the following. I'm going to go ahead and indent my existing lines of codes here by the same number of spaces, 4 in this case. And then I'm going to add one more new line down here that literally says except value error. And notice it's important that I've capitalized the V and I've capitalized the E. These symbols are case sensitive. And this is now an opportunity, after this colon, to tell Python what I want to do in exceptional cases, when the number or the input from the user is not, in fact, a number. And I'm going to say something plain like print, quote unquote, x is not an integer. I'm at least going to tell the user roughly what the problem actually is. So notice another detail. The indentation is important. Because I have try on line 1 and I've indented lines 2 and 3, those are the 2 lines of code that I'm trying. Except if I see a value error, line 5, because it's indented, is what is going to get executed in cases of those errors. Let me go ahead now back to my terminal window and run Python of number.py, enter, and let's go ahead and type in 50 again. Still seems to work. And of course, I'm trying and succeeding. Let me go ahead and try once more, this time, though, with the word cat, or really anything that's not a decimal number. And now you'll see much more cleanly x is not an integer. I'm not seeing some scary error message that I, as a user, am going to have no idea how to handle. Now you, the programmer, have anticipated that something exceptional can happen, and you've gone about actually handling the error for the user, giving them an appropriate error message instead. Let me pause here and see, are there any questions now on what we've just done by introducing try and except to handle this value error?
Is value error the only type of error you can get? Or are there other types?
Is value error the only thing you can catch? There are other errors as well, and we'll see a few of them today. And there's many, many more, honestly, that if you continue programming in Python, you're going to see a lot of them over the weeks, the months, the years to come. But the technique for handling them is going to be largely the same. Other questions on try, except, or these exceptions more generally?
Yes. Sir, actually, to use the except block, you need to know the type of error, right? Like here, you knew it was a value error. What if you can't anticipate this particular type of the error?
A really good question. So I'm being very good about catching, so to speak, the very error that I know might happen. I don't know when it might happen, because it's going to depend on the user, but I know what kind of error will happen from the int function. There is a way in Python where you can say except if anything goes wrong, and you can literally omit value error and just catch everything. The problem with that is that it sometimes hides other bugs in your code because you don't necessarily know what's going wrong. And if you don't necessarily know what's going wrong, how can you possibly handle it correctly? So bad practice. And put another way, it's lazy to do that, to just say catch everything and I'll deal with it here. So a much better practice would be to figure out what kind of errors could happen and include mention of them explicitly as I've done. Now, with that said, if you read Python's official documentation, as you'll eventually invariably do, it is not great about telling you proactively what kinds of errors can be raised in this way. So it's a bit of contradictory advice. You should do it this way, but it's not always obvious what you should be checking for. But you get better at it with practice. And some of the times the documentation does spell out what could go wrong. Let me turn our attention now back to this and point out that even though this is better code, it is more correct in the sense that I'm not just leaving it to the user to see some really ugly default Python error message that most people are going to have no idea what to do with. I'm at least handling it more elegantly, and I'm printing out x is not an integer. So it's at least more instructive. But this isn't necessarily the best way to implement this code. Why? Well, here too, I'm actually still being a little lazy. So notice that I'm trying to do not one line of code, but 2 lines of code. And this isn't a huge deal because we're only talking about 2 lines of code. But in the interest of preaching best practices, you should really only be trying to do the one or very few lines of code that can actually raise an exception, that can actually fail in some way. I am pretty sure that calling print here is not going to raise a value error. Whether x is an int or a string or a float or anything else, the format string feature of Python is going to handle printing it just fine. So really what I'm going to do is this. I'm going to move this line 3 down to the bottom of my code. I no longer need to indent it. I'm just going to execute it at the bottom of my file here. Unfortunately, by doing this, I've done a good thing by now only trying to do the minimal amount of work necessary that might raise the exception, a value error. But I fear I've introduced a new mistake. Well, let's see. What is now incorrect? Let me go ahead and again run Python of number.py, enter. Let me go ahead and do it correctly with 50. And all seems to be well. But again, let's try those corner cases, the zeros, the negative numbers, or in this case, the cat. Let me go ahead and type in CAT again, enter. Now I have a name error. So now it's yet another type of error in my code that I've introduced here. And what does this name error mean? Well, just as a value error refers to that, the value of some variable, the value that someone has typed in is incorrect, name error tends to refer to your code, like you're doing something with the name of a variable that you shouldn't. And why might that be? Well, let me turn our attention back to the code here and consider, what is it complaining about? Well, the name error is what I see down here. And it's telling me name, quote unquote, x is not defined. And notice if I look further here, it is mentioning line 6. So I know the problem is with my code on line 6. And that worked a moment ago. And I'm defining x on line 2. But let me ask the group here, why does x not, in fact, exist on line 6? Why is it not defined, even though I'm pretty sure I was intending to define it on line 2?
Maybe the scope of the variable is between the try block.
So good terminology. Scope refers to the portion of code in which a variable exists. That too, though, isn't quite right in Python. That would be true in C, C++, and Java, where indentation or curly braces tend to define the scope of a variable. But again, here in general, and this worked a moment ago, x exists once it's defined on line 2, because remember, I printed out x is 50 a little bit ago. Let's try one more hypothesis here. One more hand. Why is x somehow still not defined?
Yeah, so is it because it's local variable, meaning that like it doesn't define outside of the scope? Because like what people have mentioned, it prompts the input in try, right? But outside of it, it's undefined.
So still good instincts and good terminology too. There's this notion of local variables, which tend to exist inside of functions, for instance. Global variables, which tend to exist in entire files. In this case too, though, that's not quite the case. What's happening here boils down to order of operations. Let me come back to the code here and recall that anytime we've discussed the assignment operator, the single equal sign, that copies a value from the right to the left. But consider for a moment at what point something is going wrong. Well, the input function is probably working just fine, because we've used that a lot now to get users' input. It always returns a string or a str in Python. But what could be going wrong? Well, if I'm passing that string to the int function as its argument, it's probably the int function that's erroring. And indeed, if you think back earlier when we had the value error, it was in fact the int function that did not like quote unquote cat as input. So this is all to say that this portion of my code, highlighted now to the right of the equal sign, that's the code that's creating a problem. That's the code that was creating a value error. And in this case, we're catching the value error. But because the value error is happening on the right of the equal sign, there's no value being copied to the left. The error is interrupting that whole process. So even though we see x equals ... on line 2, the portion of that line to the left of the equal sign isn't getting evaluated ultimately, because the value error is happening too soon. And so when we finally get down to line 6, even though it looked like I was defining on line 2, and I would have defined x on line 2 if all had gone well, we didn't get to the part where the value is copied from right to left because the value error happened first. So this code is just incorrect now. So how do I go about solving something like this? Well, it turns out that there's another feature of the try and except syntax that Python supports, which is that it also supports the keyword else. Now, we've seen else before. If you think back to our discussion of conditionals, we saw if, we saw elif, we saw else, which was kind of this catch-all, what you should do in the event that nothing else is relevant. That's kind of the same intuition here for the try except feature of Python. What you can do is this. You can try to do the following, as I've done, except if this goes wrong. But if nothing goes wrong, else go ahead and do this. So this is one way I can solve this same problem now. No matter what now, Python is going to try to execute line 2. If something goes wrong, it's going to execute lines 3 and 4 to handle that value error. However, if you try and this code succeeds, then there is no exception to handle, so you're then going to execute this line here. So it's a little confusing perhaps in that we're now using else both for conditionals, if, elif, 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 else, and we're also using else with these try except blocks, but that's OK. That's part of the language. That's one of the features. So now if I rerun this code in my terminal window, Python of number.py, let's do something correct like 50, I see that x is 50. So line 1 is executed. We're trying to do the following. Line 2 is executed because the conversion happened successfully and the number 50 gets copied from right to left. The exception does not happen. So we ignore lines 3 and 4. We jump immediately to line 5 and 6, which prints out the result. By contrast, though, let's do this one last time. Python of number.py, let's type in cat or, again, any other word and hit enter now. We don't see what x is. Rather, we see, quote unquote, x is not an integer, which is what's being handled in my except clause. All right, let me pause here, because that's a lot of new syntax, and see here if there's any questions on try, on except, on else, name error, or value error.
Can you please repeat try function?
Repeat the name error. What's the problem with the name error?
Yes, yes.
Yeah, so let's just rewind a couple of lines here before I fix this problem by now getting rid of the else. A moment ago, we had code that looked like this, whereby I was getting a name error, Python of number.py, enter, typing in cat, that looked like this, where name x is not defined, and the problem was on line 6, according to this output in Python. Well, let's think about this now deductively. Let's try a different approach. On line 6, I'm seeing an error that name x is not defined. OK, Python's already telling me x does not exist at that point. So how could that possibly be? Well, where should x be defined? Well, presumably x is defined on line 2 up here. So what could go wrong? Well, if the user has inputted something that doesn't look like a number, like the word cat, passing cat, the return value of input, as the argument to int to convert the word to an int makes no sense. You can't convert a cat, C-A-T, to an integer at all. So the int function is raising a value error at that point, and the error is being handled with this code here. But notice, this line 6 is not indented. It's left aligned with the rest of my code, which means no matter what, line 6 is going to execute. It's going to execute whether I typed in 50 or I typed in cat. But if I typed in cat, again, x never gets a value, so it's not defined here on line 6. So when I introduced finally the else statement, that makes sure that these things are mutually exclusive. I only execute the else if I tried and succeeded up above. Well, let me propose that we refine this just a little bit further as well and consider how we might improve this example a little bit more. It's a little unfriendly of me to be rejecting the user's input after they fail to provide an integer and just quitting the program, really, right? It'd be more user-friendly if I just prompt or reprompt the user again and again. And in the chat, if you could, what's the feature of Python that you can use if you want to do something again and again and again until such time as the user cooperates and gives you what you're looking for, like a number? So yeah, loop, loop, loop. So a loop is something that happens again and again and again. And maybe we can use that same mechanism, a loop, in order to prompt the user for x. And if they don't give us a number, prompt them again. And if they don't, prompt them again and again and again. We don't need to just quit out of the program so quickly. So let me propose this. Let me propose here that I improve this code by deliberately doing this. Let me induce a infinite loop at the very top of my code with while true. Recall that the while keyword induces a loop, a cycle that behaves like this, and it asks a question, a Boolean expression that needs to evaluate either to true or false. Well, if I want this thing to loop forever, at least initially, we'll just say while true, because true is true, so this has the effect of doing something no matter what forever, unless we break out of it early. Now I'm going to go ahead and do this. I'm going to go ahead and move my try except code indented underneath this loop so that I'm trying to get an x. If I have a value error instead, I print out x is not an integer. But this time, what do I want to do if the user does try and succeed in giving me a number? Well, I can do this. I can just break out of my code here. And down here now, I can use that same line of code from before, an f string that says x is, and then in curly braces, x again. So what's going on here? I think this code now, because I've added the loop, is going to have the effect of trying at least once, maybe a second time, maybe a third time, maybe 500 times until the user finally gives me what I want, which is an integer. And once they do, once there's no value error happening, then I break out of the loop and line 9 executes as I would hope. So let me go ahead and try executing this version. Python of number.py, enter. What's x? Let me go ahead and type in the easy thing first, 50. X is 50. What just happened in terms of the control flow of this program, the flow of my logic? Well, I first found myself on line 1 inside of a loop. Hopefully, I'll get out of this loop. What did I then do? On lines 2 and 3, I tried to get input from the user and convert it to an int. Well, I was a nice guy this time, and I typed in 50, which looks like and is a number. So the int function converted it just fine and stored it from right to left in x. Except value error, there is no value error, because if I typed in a number, there's nothing exceptional happening. This is a boring, good execution of my program. So what happens? I break out of the loop. So again, the else clause is associated with the try, not with the except. And once I'm out of the loop, of course, I'm just printing out what x is. Well, let's try the other scenario that might happen. Python of number.py, enter. What's x? Let's try cat or any other word. Enter. This is now a new feature. I'm being informed what I did wrong. X is not an integer, so I'm getting some useful user feedback. But notice again, I'm prompted, what's x? Well, let me try typing in dog. X is not an integer. What's x? Let me try bird. Enter. X is not an integer. What's x? And suffice it to say, this will happen now forever if I'm in an infinite loop until I try and succeed, at which point I break out. So let's try again. 50, enter. Now I'm out of the loop, and I'm printing out what x actually is. All right, let me pause here and see if there are any questions. The logic is almost the same, but what is different now is I'm in a loop, and I'm using the keyword break in Python to deliberately break out of the loop when I'm ready to, once the user has cooperated.
Do we really need to break? Can't we just print? Or what keeps us from just printing?
Good question. So let me try that. Couldn't I just print? Well, let's see what happens if I do that. Let me move this print line at the end into my loop here, thereby shortening the program. And in general, that's been a good thing. Python of number.py, enter. Let me go ahead and type in 50. OK, x is 50. What's x? OK, maybe it's 49. X is 49. OK, maybe 48. Unfortunately, I think you're laughing. You see it. I never break out of the loop, which maybe that's a feature. Maybe you want this to be your program, but I didn't. I'd eventually like this game to stop. So I need to break out in that way. But I can do it a little differently. And let me propose that we modify this a little bit. But first, any other questions on this syntax here? Let me rewind to the prior version.
Hi, can I use break or in exception, except in else? For example, in another print, when you use print in the else, you can use print together with break or something like this?
So you can use break inside of loops to break out of loops. And you can use it inside of a conditional, like an if, an elif, or an else. You can do it inside of a try, except, else statement too. Anytime you're in a loop that you want to break out of, you can use this keyword break. I'm using it in the context of exceptions, but it's not restricted to that. And let me show you too, it doesn't even have to be in the else. If I wanted to, I could actually do this. I could get rid of my else, and I could go back to line 3, add another line that's indented, line 4, and break out here. Now, why is this logically OK? Well, consider what I'm now trying to do. I'm trying to execute line 3 and converting the user's input to an int. And I'm trying to store the result from right to left in x. If something goes wrong, the code we've already seen is immediately going to jump to line 5 and then 6 to handle the exception. But if nothing goes wrong, my code presumably should just keep on executing line by line. So I could technically, logically put the break here and watch what happens when I run this version. Python of number.py, 50, enter. It worked. I broke out of the loop. Now, which way is better? Honestly, I think it could go either way at this point. This program's so relatively short that even though I'm trying to do two things now, one of which, the break, is not going to fail. Like you either break or you don't. There's no piece of data from the user that's going to influence that. We don't strictly need to have those 2 lines of code there, but it's only 2 lines, so I think it's OK. And if you recall our discussion in the past, not just of correctness, does the code work as it should, but design, I think you could argue it either way. If you prefer the readability of this and the fact that you don't have an else, that's fine. If, though, you prefer to minimize just how many lines of code you're trying to execute in case something goes wrong, the else is a reasonable approach too. Well, allow me to propose 2 now that we refine this further. I think we're at the point where it's pretty darn correct. But suppose now that I find myself today and tomorrow trying to get numbers from the user quite a bit. It would be nice, as we've seen, to maybe just invent my own function, getInt, to get an integer from the user both today and tomorrow and beyond. And heck, maybe I can even share that function with other people if they want to write programs that get integers from users. So how might I go about doing this? Well, let me go ahead and propose that we do this. Let me get rid of the print line, but keep most of my loop here. Let me define a function called getInt that takes no arguments for now. And I'm going to go ahead and indent all of the code I already wrote underneath getInt. So now I have a function called getInt that tries to do the following. Try to get an int from the user. If something goes wrong and there's a value error, yell at them with x is not an integer. Else, break. But it's not just breaking that I want to do here. Now that I'm in a function, recall our discussion of return values. If you're inventing your own function whose purpose in life isn't just to print something on the screen like a side effect, but is to hand back a value, to hand you back a value, like on that same Post-it note from our discussion of functions, well, you need to return x explicitly. How do I now use this function? Well, as soon as we start making our own functions, it tends to be convenient to define our own main function as well. That's the main part of our program. And I'm going to keep this simple. I'm now going to say x equals getInt. And then on the next line, I'm going to do that print from before, quote unquote, x is, in curly braces, x. And at the very bottom of my program, recall, I'm going to call main so that no matter what, I'm invoking my main function after everything's been defined. Well, let's see how this works. Let me go ahead and run Python of number.py, enter. Let's type in 50, and it seems to work as before. Let's go ahead and run it again, typing in cat, C-A-T this time. X is not an integer, and I'm being prompted. Dog, and I'm being prompted. Bird, and I'm being prompted. Fine, 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 50. That's an int, and so it is printed. So what's worth noting here? Well, I'm manifesting a couple of good properties here. One, I've kind of abstracted away this notion of getting an integer. And even though I just artificially hit enter a whole bunch of times just to hide that function for now, it needs to be there, but we don't need to see it at this point. Notice that now this entire program really boils down to just these 3 lines of code now. Why? Because I've abstracted away that whole process of getting an int from the user into this new function of my own called getInt. But can I improve upon this? Well, let me go ahead and undo all of those blank lines and pull this up just so we can see more on the screen at once. Can I tighten up my implementation of getInt? It is correct. I claim this is correct. It's handling errors and it's returning x. But I don't, strictly speaking, need to write the code as long. What else could I do? Well, let me propose that if all you're doing on this line 13 is breaking, and then immediately after that, per the indentation, you're executing return x on line 14, why are you wasting everyone's time? Once you know you're ready to return the value, you could just return x. And so in my else, I could break out and return a value. So here too, return is used to return values from functions. Break is used to break out of loops. But it turns out that return is sort of stronger than break. It will not only break you out of a loop, it will also return a value for you. So it's doing 2 things for once, if you will. But can I make this even more compact? If my goal is to just tighten the code up, even though it's already correct, can anyone think of a further refinement, whether you've programmed in Python before or not? Can I shorten this implementation further, just a little bit, if only to decrease the probability that I've made a mistake by having fewer lines, and just make it a little easier to read because it's shorter? Any suggestions for tightening up my implementation of getInt?
You can just return the value on the try function when you're trying. You take the input x and then return x.
Good. We can just return x a little higher up. And let me correct folks as we go. It's not a try function. It would be a try statement, technically. A function typically has a parenthesis and another one. In this case, it's just a statement, but we can do exactly that. I don't technically need the else. If I really want, I could do this. Right after line 9, I could return x here. Or recall our discussion of defining variables unnecessarily sometimes. Like, why define a variable here if you're immediately going to use it here and then never again? So we could avoid a new line here. And I could avoid even defining x explicitly. I could just say something like this. I could return int input, quote unquote, what's x. I can do it all at once. Now, which is better? I don't know. I mean, again, this is where reasonable people might disagree. I'd argue that on the one hand, we're tightening up the code. We're using fewer lines. It's easier to read, lower probability that I've made a mistake. On the other hand, it's a little more complicated to understand, perhaps. It's a little less obvious where I'm returning from. So I think arguments can be made either way. At the end of the day, what's important is that you've done this consciously. You've made a decision to do it this way or this way, and you can justify it in your mind, not that your answer is, it worked, so I left it alone. Like, have a good reason. Come up with a good reason, and that will come with experience and practice. Well, let me propose, too, that we make one other refinement here. Suppose that you're finding your programs to be a little noisy, and it's a little obnoxious that you keep telling the user x is not an integer, x is not an integer, x is not an integer. What if you want to make things a little gentler and just prompt the user again with the same words, what's x, what is x, what's x, again and again? Well, you can do that as well. And it turns out that if you want to handle an exception in Python, but you want to pass on doing anything with it, so you want to catch it, but you essentially want to ignore it. You don't want to print anything. You don't want to quit the program. You just want to silently ignore it, like if you're talking in a room full of people and it's your turn to talk and you're just like, pass. They're still calling on you, but you're not doing or saying anything more. Well, we can add this keyword to our code here. Let me go back to my program here. And instead of printing out again and again, x is not an integer, I could just do this. I could pass on handling the error further. I'm still catching it. So the user is not going to see a scary message even mentioning value error. My code is catching it, but I'm passing on saying anything about it. I'm going to stay in the loop. I'm going to stay in the loop and keep prompting and reprompting the user. So now the effect looks a little something like this. Python of number.py. Let's type in cat. What's x again? Let's type in dog. What's x again? Type in bird. So it's just a little maybe more user-friendly in that you're just reminding the user what you want. Maybe it's worse. Maybe it would be helpful to tell the user why you're prompting them again and again. It's not obvious, so it could go both ways. But again, it's just another mechanism now for handling these errors. We use the except keyword to catch a specific error, but we don't have to handle it more than that. We can just pass on doing something further. Let me pause here and see if there's any questions now on try, accept, else, or pass?
Okay, yeah, no, I was just kind of curious, I guess, about the idea of when you were indenting with the getInt function, for example. Because I'm noticing, you know, obviously going through it with the whole logic and breakdown of the entire function, you know, while true, do this. But I'm just kind of curious on elaborating with the indentations for the code more.
Yeah, so the indentation is deliberate logically. Some languages don't require as rigorous indentation. You can use curly braces or other symbology to make clear what is associated with what. In general, anytime you indent something in Python on this line, anytime you write a line of code in Python that's here, and the lines below it are somehow indented, that means that those lines are somehow associated with that first line. And presumably, those indented lines should only be executed if the first line told the computer to do so. So concretely, what does this mean? On line 6 here, we're defining a function called getInt that takes no arguments, colon. Everything that's indented by at least 4 spaces hereafter is part of that function. Why? That's just the design of the Python language. Frankly, I think the designers got tired of seeing really ugly code in languages like C and C++ and Java that don't necessarily enforce indentation to this extent. So now it's baked into the language. And my chronology might be a little off there, but there's been many languages that are looser than Python when it comes to indentation. The indentation is meaningful on line 7 too, Notice that because the while true is indented by 4 spaces, that just means it's part of the getInt function. But notice below the while true statement, there's 8, there's 12, there's 8, there's 12 spaces here. And I'm just quickly counting the dots. That means that all of the lines I've just highlighted are inside of that while loop. While true means to execute lines 8 through 11 potentially again and again and again. And now lastly, on line 8, because we have try and indented below it is line 9, that just means that what you should try is what's on line 9. And similarly, on line 10, below it, we have indented line 11. You should only pass when there is an exception of a value error. So the indentation just means what is associated with what. And once you get comfortable with that, you'll see that it helps, the indentation alone helps explain the logic of your program. And it has a wonderful side effect that for yourself the next morning, for your colleagues, your family, your friends, your teachers, your code is much more readable as a result. It's not one big mess of a blob of text. Other questions now on try, except, else, or pass.
Yeah, thanks. Two questions. Question one, once you say pass, can the caller still learn anything about this error through a system variable or whatever? And question two, problem set 0 referenced some string methods, including is numeric. Is it any different to go via is numeric here?
A good question. So on the first question, if I'm handling the error in this way, the caller is not going to know anything about it. That's the point of my handling it, so that main or other callers don't know that anything technically went wrong. On the second question, is numeric is another function that you can call that can look at a string and determine, is this in fact a number? I could use a mechanism like that. I could use a conditional. If this looks like a number, then pass it to the int function and go ahead and convert it to an integer. That's totally fine. I would generally say that the Pythonic way of doing things is often, for better or for worse, to try things, hope they work, but if they don't, handle the exception. So other languages are more in favor of checking if, elif, else, and all of these conditionals. Python tends to be a little more of the mindset, try it, but just make sure you're handling the error. So this would be the Pythonic way of doing it. Your way, though, checking with a conditional, is it a number first, is totally reasonable too, if you want to go that way. Well, let me propose some final refinements to this program that really just kind of tighten things up one additional step to improve the implementation of this getInt function. Let me propose that we not hard code, so to speak, that is, type manually x all over the place. Let's make this function getInt a little more reusable. Right now, notice that I'm just kind of using the honor system that, well, main is defining a variable called x, and getInt is asking for a variable called x. But it would be nice if the caller, main, doesn't have to know what the callee is naming its variables, and vice versa. So caller, to call a function means to use it. The caller is the function that's using it. The callee is just the function being called. It would be nice if I'm not just hoping that x is the same in both places. So let me propose this. Let me propose that we actually add a parameter to getInt like this. What's x? That is to say, if main wants to use the getInt function, well, then main should probably tell the getInt function what prompt to show the user. Just like the input function, recall, that comes with Python, it's up to you to pass in a prompt that the user then sees when the human is asked for input. So how do I make this work here? I can go down to my definition of getInt, and I can say, all right, getInt is going to take a parameter now called prompt. I could call it anything I want, but prompt in English is pretty self-explanatory. It means what do you want, the message the user will see. And now down here, when I actually use input, I don't have to presumptuously say what's x, because what if the program, the caller, wants to ask for y or z or some other variable? I can just pass to input whatever prompt the caller has provided. So now I'm making more reusable code. It still works just the same. I haven't changed the functionality per se, but now it's a little more dynamic, because now getInt doesn't have to know or care what variable is being asked for, what's being asked for. It just needs to know what prompt it should show to the user. So if I now run this program down here again, prompt number.py, enter, what's x? 50. Still seems to work. Let's run it again. Let's type in cat. It still seems to work. And if I type in cat, dog, bird, or anything else, it will keep prompting me with that same prompt, making this code, therefore, all the more usable. Now, it turns out, too, you can even raise exceptions yourself using Python's raise keyword, but more on that another time. So in the coming days, the coming weeks, the coming months, as you write more code in Python, you'll see that errors are inevitable. Sometimes there's syntax errors, which you got to just fix if you even want to run your program at all. But they could be name errors, for instance, variables that you meant to define but somehow didn't. Value errors, where maybe the user didn't cooperate and provided you with something that you weren't expecting, or a whole list of other possible errors or exceptions. But now, hopefully, you know how you can handle these errors and respond to them in any way you like. This, then, was our look at exceptions, and we'll see you next time. All right, this is CS50's Introduction to Programming with Python. My name is David Malan, and this is our week on libraries. So libraries are generally files of code that other people have written that you can use in your own programs, or a library is code that you've written that you can use in your own program, but maybe not just this program, but another and another as well. So Python supports exactly this idea, this ability to share code with others, share code across your own projects, and it does so by way of what it calls module. A module in Python is just a library that typically has one or more functions or other features built into it. Generally, the purpose of a library, or a module specifically, is to encourage reusability of code. If you find yourself using the same types of functions again and again, the same functionality, if you find yourself copying and pasting from an old project into your new project, odds are there's an opportunity there to factor out that code that you keep copying and pasting, that you keep reusing, and put it into a library that you can then load into your programs moving forward, so as to not just copy and paste it and have all these different copies all over. So what are some of the modules or libraries that Python comes with? Well, Python comes with a random library, literally, which is to say that when you install the Python interpreter on your Mac or PC or somewhere in the cloud, not only do you get Python, you get a whole bunch of modules as well. Now, these modules provide you with functions that you don't have access to just by default, like you do print and input. Print and input and other such functions just work in Python. But sometimes functions are tucked away in these modules, so you have to be more deliberate about loading them into the computer's memory. So somewhere on the computer's hard drive, once you've installed Python, there is also, it turns out, a file probably called random.py that someone else wrote, probably long ago, but that you have access to. And in that random.py file, there's probably one or more functions that you yourself can use in order to do things randomly. That is to say, how could you flip a coin in a program in Python? How could you pick a random number between 1 and 10 in Python? Well, you need a bit of randomness. And while you could figure out mathematically how to write functions like that yourself, it's a lot easier to stand on the shoulders of others who've already solved that problem for you, so you can focus on the problem that you yourself want to solve. So for documentation on most any Python module, you go to the official Python docs, and you go to a URL like this where the documentation for that specific module lives. And within the documentation, you'll see a list of the functions or other functionality that some module provides. But how do you go about loading a module into your own program so that you can use the functions in that module? Well, we need a new keyword in Python, and namely, it's import. The import keyword in Python allows you to import the contents of, the functions from, some module in Python. Well, how might I go about using this in practice? Well, let me propose that there exists in that random module this function, among others. So I have copied and pasted from the documentation this summary of a function called choice. Now, the function exists in the random module, so to speak, not a random module, the random module. And so generally, the documentation describes it fully like this. Random.choice is how you would technically call this function, though we'll see alternatives to that. In parentheses, there's a parameter called seq for sequence. And sequence generally means a list or something that is list-like, if you have a list of numbers or strings or anything everything else. And the documentation elaborates. Well, how can I go about using this function to solve perhaps a familiar problem? Well, let me go ahead and open up VS Code here. And let me propose that we implement a program that simulates flipping a coin that in the US heads or tails, the idea of which is to pick a decision with 50-50 probability. 50% probability of heads, 50% probability of tails. Or you can use some other mechanism like that. Well, let me go ahead and open a program with code called generate.py, because I want to start generating a whole bunch of random information. The first of which is just going to be a coin toss. Now, how do I go about using that function? Well, I first have to import the random library. So literally the first, or among the first lines of my file, should be import random. And that just gives me access to all of the functions in that specific module. Now suppose I want to flip a coin. Well, I can do random.choice per the documentation a moment ago. And that again takes a sequence. What's a sequence? It's a list or something that's list-like. And we know about lists. We've used lists to iterate over numbers. We've used lists to iterate over students at Hogwarts. Let's go ahead now and iterate over just a list of two sides of a coin. Heads, quote unquote, or tails. Now, I could call these anything I want. These are my strings. I just want to simulate a tossing a coin, so I'm just going to say in all lowercase, heads and tails. But notice the syntax. I have heads and tails in double quotes. That's because they're strings. I could also use single quotes, so long as I'm consistent. There's a comma between them, which means the list has two elements. There's square brackets to the right and the left, which indicates that this is indeed a list. That's the syntax, recall, for defining a list in Python. And then lastly, there's something more familiar. There's the parentheses outside of those square brackets, but those are just the parentheses that belong to the choice function and specify where its parameter gets passed in. But again, unlike past functions, I have to specify what module this function is in, at least for now. And so I do random.choice to call this specific function. All right, well, it's one thing to flip a coin, picking between those with 50% probability. And that's what random.choice does. It takes in a list, and it returns to you one of those values randomly with equal probability. Because I've passed in 2 items, I've got a 50-50 chance. If I passed in 3 items, it'd be a 33% chance for each of those items, and so forth. Python does the math for you. But I want to store the value of this in a variable. So let's define a variable called coin equals whatever the return value is. So this is indeed like flipping a coin. I'm going to store in a variable called coin whatever that value is, heads or tails. And now, just so I can see what's going on, let's go ahead and print out the value of that string coin. All right, let me go ahead now and run this program in my terminal window. Python of generate.py, enter, and it looks like the first coin toss was the heads. Let's go ahead and run it again, and it looks like it was heads again. Maybe you want to chime into the chat here. If I run it a third time, what's it going to be this time? If you want to type your thoughts in the chat. You might think there's a bug here, but this is probability in action. If I go ahead and hit enter a third time, there, it's actually now tails. And again, 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 heads. Now, if we did this an infinite number of times, it would indeed work out to be 50-50. If we only do it a few times, it might not work out as cleanly. But that's how probabilities indeed work. All right, so I've got that now working. Could I have implemented this in a different way? Well, let me show you an alternative to actually using the import keyword alone. And let me introduce the keyword from in Python. So from is a keyword in Python that you can use when importing functions from a module, but it allows you to be a little more specific than import alone. So if I go back to my code here, it's worth noting that what technically I'm doing here by importing random is I'm technically importing everything that's in that module. So not just the function called random.choice, but a few other functions as well. So instead of using this line of code at the top of my file, import random, which will technically give me access to all of the contents therein, a downside of that is that I have to type in random.choice, random.this, random.that, because all of the functions I'm calling have to be associated with the scope of that module. Well, suppose that I just want to call the function as its name, choice. I can do that as well. Let me replace this first line here with from random import choice. And what this does effectively is it loads the function's name, choice, into my current namespace, into the scope of the file I'm working in. What that means is that I now no longer have to specify which choice function I mean. I can just say choice. And so it loads it into the local namespace, that is, into my local vocabulary, if you will, so I can just now say choice. This might be advantageous In what cases do you think? When might you want to import the name of the function explicitly like this, as opposed to just saying random.choice throughout your code when calling a function? Any instincts here for this alternative import using from?
Hello, I'm Mohammed Omar from Egypt. Maybe if we have a variable that its name is basically like choice, if I have a variable called the choice, so I need to differentiate which choice I choose. So I'm going to choose random.choice.
Yeah, really good instincts. By using the first approach, by just importing random, you're making sure that all of its contents are associated with, are scoped to the random module so that you can have your own choice function. You can have your own choice variable. You can use the same names as all of the functions or variables that are stored inside of that file without them colliding, so to speak. And this is a good thing. In older languages, it was the case that if you imported someone's library, you better hope that you're not using the same functions or variables as they are, because you might in fact have some kind of conflict. Python and certain other languages allow you to scope the names of those functions and variables to the file or the module that they come from, so that's a good thing. But honestly, this is such a short program. Or, equivalently, maybe I'm using the choice function in so many places, calling random.choice, it's just making my code longer and longer and longer. Marginally so, but it's just getting ugly and annoying. I can simply import choice and now tighten up my code a little bit. So as with so many decisions in the past, there's not necessarily one right approach or another. It depends. But I think for those very reasons, sometimes it's better to do what we did the first time, which is only import the module so as to retain the scope therein. Well, let me propose that we transition to another function that comes with Python's random module. And that's this here from the documentation, randint. It's a bit hard to say, but it implies get back a random int. And if you read the documentation, it's a random int that's between a and b inclusive. So if you were to pass in 1 for a and 10 for b, you would get back a number between 1 and 10 inclusive, including the 1 and including the 10 potentially, each with a 10% probability. So how might I go about using a program like this? Well, let me come back to my generate.py file. And why don't we go ahead and try generating a random number between 1 and 10. You might do this frequently in the real world when you just want someone to pick a random number. You tell them as much and the human responds. Let's get the computer to do the same here. Let me go ahead and delete my 2 lines of code at the bottom, but keep my import random. And let's go ahead and define a variable, this time called number. Set it equal to the return value of random.randint. And now pass in a value of 1, and b, a value of 10. And now let's go ahead and print the number. I'm going to go ahead in my terminal window and run Python of generate.py and hit enter. 4. Python of generate.py and hit enter. 8. Again. 9. Again. 7. Again. 10. Again. 2. Again. And we can do this all day long. And if we add all of those up, they should end up being with 10% probability each. Now, how might you use this information? Well, maybe we're playing a guessing game, or maybe we're trying to randomize the behavior of some character in a game. You can imagine using very simple building blocks like this, just kind of spicing up your program by getting it to do things a little less predictably because you're choosing these values seemingly randomly. And you're deferring to Python to actually do the generation of these numbers using its own algorithms and its own math. Well, what more could we do here? Let me propose that we introduce another function that comes from this random library, yet another that you yourself don't have to implement, shuffle. If you read the documentation for shuffle in the same random module, you'll see that it takes in a list, for instance, of values and just shuffles them up. It randomizes them. Like a deck of cards here, you might shuffle them so as to put them into seemingly random order. Well, how do I use this based on this function's name? Well, let me propose that we go back to VS Code here, and let me go ahead and this time do the following. Because I need to shuffle something like a deck of cards, let me go ahead and not just import random, but let me give myself a variable called cards that's going to be of type list. And just so I have something to shuffle, I don't need all 52 cards in a typical deck. I'm just going to shuffle 3 cards, a jack, a queen, and a king. I could call those strings anything I want, but I just wanted a list of some values so as to shuffle them up. That is, randomize the order they're in. Well, how does this now work? If you read the documentation for random.shuffle, you'll see that it shuffles the argument in place. That is, unlike many of the functions we've seen, it doesn't return to you a value that contains the shuffled cards in this case. It actually shuffles the list it's given itself. So what this means for my code is that I need to do something like this. random.shuffle and pass in the variable containing those cards. And then on a final line here, how might I go about printing the cards? Well, I could do this, and I could say print cards. But if I do that, I'm actually going to see Python syntax for lists. And it's just going to format it in its own way using commas and the like. I want to print these cards out one at a time just because I think it'll look a little better. So we can use some of our syntax from loops and say something like this. For card in cards, go ahead and print out the current card. So what's now happening here? Line 3, I'm defining a list of 3 cards in this order: Jack, Queen, King. I'm then shuffling those same cards on line 4. And then on line 5, I'm using a for loop. For each of the cards in that list, print it out one at a time. And because I'm using print, one line at a time. Well, let's see the results. Down here in my terminal window, I'm going to run Python of generate.py and hit enter. Queen, King, Jack. Seemingly shuffled because that's not the order I defined earlier. Let's do it again. Queen, King, Jack. OK, that happens to be the same, but let's see. This could just be bad chance. There we go. Jack, Queen, King. Doesn't look like it's shuffled, but at least we're getting back different orderings now. Again, Jack, Queen, King. Not so good. Jack, Queen, King. Not so good. This is someone you probably want to play against with cards. Queen, Jack, King. There we go. But of course, we only have 3 cards here, so there's not that many permutations we might see. And if we do this over time, we will see all of them. But if we had, of course, 13 or 52 cards, we'd see a lot more permutations instead. So we have now these 3 ways to generate random information. One is simple coin toss if you want to start some kind of athletic event. One, pick a number between 1 and 10 if you want to decide something based on that. And now using shuffle, we can even take in a list of things and shuffle them about so that we get some kind of random behavior. Well, let me pause here and see if there's any questions yet on random, on modules, or any of these 3 functions.
Yeah, can we increase or decrease the probability of cards if we want to? For example, there is a 33% chance of probability. So is there any chance to increase or decrease the probability?
Can you set these probabilities, not using these same functions? Can you set the probabilities? But you can absolutely implement some of your own functions or use more sophisticated functions that do exist in this library and others to exercise more control. These are meant to be very user-friendly and simple functions, certainly the ones we looked at, that give you equal probability for all of those. But absolutely, you could skew things, though hopefully if you're implementing a gambling game or the like, you're not actually making some cards more probable than others. Allow me to turn back now to our implementation here of this randomness and consider how we might leverage other types of functionality that aren't necessarily in this specific library here. Well, it turns out that Python also comes with a statistics library, and this contains all sorts of functions for doing things more statistical in nature, namely calculating means or medians or modes or other aspects of a data set that you might want to analyze. So how might we use the statistics module in Python? Well, we might first just take a look at its documentation like any other module in Python, and we'll see within that library that there's a whole bunch of functions. And one of those functions is one that's quite simple. It's average, a function that allows you to calculate the average of some numbers that you've passed in. Let me go ahead and in VS Code in my terminal window, open up a new file called average.py. And at the top of this file, I'm going to import a different library this time, namely the statistics module in Python. And now I'm going to go ahead and call a function that I know comes in that module, namely mean, for the average of some values. And I'm going to call statistics.mean. And I'm going to pass into this function mean a list of some values. And let's suppose that I'm quickly trying to calculate what my current grade average is in school, and I did really well on my first test and I got 100%, and on my second I did well but not as well and I got a 90. And ironically, I'm not very good with math, so I'd like to figure out what my average now is between those 2 tests. So let me go ahead now and in this list type in the number 100, 90, thereby passing in a list of 2 values, 2 ints, 100 and 90, and outside of those are the parentheses because, of course, this is now the argument I'm passing to the function called mean, and this function mean is in the module called statistics. Well, it's not that interesting to just calculate the mean if I don't actually see what it is, so let me additionally pass the return value of that mean function to the print function as usual. Let me now in my terminal window in VS Code type in Python of average.py and hit enter, and voila, as you might expect, my average is 95%. So the difference here is that I'm just using a different module that still comes with Python, but I need to import it instead of, for instance, the random module instead. And this time I know from the documentation that there exists a function called mean. Well, it turns out there's even more functionality that comes with Python and that comes with other modules in Python. And there's this feature generally known as command line arguments. This is a feature not just of Python, but of languages more generally that allow you to provide input not when prompted inside of a program, as happens whenever we call the Python function input, but rather there's this feature, command line arguments of programs, that allows you to provide arguments, that is input to the program, just when you're executing it at the command line. So up until now, for instance, recall that we've generally run Python of something.py. For instance, Python of hello.py. And I've never once really executed any words or phrases after the name of the file. But I could. In fact, when you're running programs in a command-line environment like we are, you can provide any number of words or numbers or phrases after the command that you're typing, and all of those will somehow be passed in as inputs to the program itself. You don't have to prompt the user for one thing at a time by manually calling that input function. So what does this mean in real terms? Well, let me go ahead back into VS Code here, and let me propose that we consider how we might leverage a certain module. I'm going to go ahead and create a file called name.py. And I'd like to use a new module this time that's going to give me access to values that have been typed at that command line. But what's this module going to be? Well, this one's going to be called sys. And sys, short for system, contains a whole lot of functionality that's specific to the system itself and the commands that you and I are typing. The documentation for this module is at this URL here, and it lists all of the various functions and variables and the like that come with that module. But we're going to focus on something a little more specific, namely this thing here. It turns out in the sys module in Python, there is a variable that just magically exists for you called argv. It stands for argument vector, which is a fancy way of describing the list of all of the words that the human typed in at their prompt before they hit enter. All of those are seemingly magically provided to you via Python in a variable called sys.argv. This variable is a list, which means that the first element's going to be the first word that you typed, the second element's going to be the second word that you typed, and so forth. And by way of this list, then, can you figure out what words did the human actually type at the prompt and maybe use that to influence the behavior of your own program? So what does this mean now in real terms? Well, in this new tab called name.py, let me go ahead and import sys. Within that sys module is going to give me access to sys.argv, but how might I want to use it? Well, let's do this. Instead of writing a hello world program that all of these times has just looked for the return value of input to figure out what the user wants me to print, let's go ahead and just expect the user to tell us when they run the Python program itself what their name is. And suppose this time I'd like to generate a whole bunch of name tags, initially just one, and in the US here it's very common to wear a sticker on your lapel that says, hello, my name is David, so I want to print out some text that resembles that. The idea being maybe I could enhance this program someday to even send that text straight to the printer and dynamically generate those name tags. Well, let me go ahead now and do this. Let me go ahead and print out, as always, hello, but I'll say a little something more this time to make things more interesting. Hello, my name is, quote unquote. And then after that, I normally have been in the habit of calling input, storing the return value in a variable, and passing in the name of that variable here. But I'm going to instead jump right to this, sys.argv bracket 1. And that's it. I'm going to have a program here that says, hello, my name is, followed by whatever is in sys.argv bracket 1. And notice sys.argv again is a list. And recall from our discussion of loops and intern lists, we use this square bracket notation to get at the various elements inside of a list. All right, let me go down now into my terminal window and run Python of name.py. But this time, rather than just hit enter and wait for the program to prompt me for my name, let me proactively just tell this program what my name is at the so-called command line. Here we go, DAVID separated with a space from the name of the file, so that now when I execute Python name.py David, I see on the screen, voila, hello, my name is David. So based on this demonstration alone, I think we can infer exactly what's going on in sys.argv, even though it sounds certainly at first glance rather complicated here. Let's look up. At sys.argv, I'm going to bracket 1 here. So clearly, sys.argv bracket 1 is storing DAVID, but it's 1. In the past, when we looked at loops, recall that we said that they were 0 indexed. That is, the first element is 0. The next element is 1. This next element is 2, and so forth. And yet here I am treating it as though my name is at the start of the list 1. Well, let me ask this question. What is probably in sys.argv of 0? What is probably in sys.argv of 0? The very first element actually in that list.
Oh, yeah. I think it's like in C, the name of program.
Indeed, it's indeed, like in C and other languages, the name of the program. Well, if we consider what it was I typed, I certainly typed Python, because that's the name of my interpreter, and we don't really need to know that because we're using Python itself. But after that, I did type 2 things. I typed name.py, as I've done so many times, anytime I want Python to interpret a program I've written. And it turns out by convention, what Python does is it stores in sys.argv the name of the file that you're executing or interpreting, followed by any number of other words that you typed. So all this time, we could have been accessing the name of the program, which frankly isn't all that interesting, but we can also now access words that are typed after that prompt as well. But of course, if I don't type anything in, what might happen here? This might be naive of me to assume that there's always going to be something at location 1 in sys.argv. Let me go ahead and try this. Python, name.py, and no, I'm not giving you my name because at this point I might not even know that you want my name to be typed. So let me hit enter now, and uh-oh, we see now an error. A so-called exception in Python. This one's a new one. This one's an index error that elaborates list index out of range. And turns out this is actually one of the most common mistakes in programming, whether using a list in Python or arrays or vectors in other languages, is to try to access some element that does not exist. You try to go too far to the left, or you try to go too far to the right in this object that is just a list of some values. So of course, the mistake here is that I'm assuming there's going to be something at location 1 when really it's location 0 that's the only one that has a value. But fixing this is not going to amount to doing bracket 0, because now if I go ahead and rerun this program with no other words after name.py, it says, hello, my name is name.py, which is fine if we're making a name tag for the program, but that's not, of course, what my goal here is instead. So if the fix is not just to change the 1 to a 0, how else might I handle this error? How else might I handle this error? This index error that happens if the user just doesn't remember to or doesn't know to type their actual name at the prompt.
We could always put an exception into the program saying if there's nothing at location 1, we just come out to say, well, okay, we haven't got a parameter or something. But if there is, you continue along with the program.
Perfect. So if I might simplify, we can try to execute this line of code, except if there's an error, we'll deal with it in some other way. Now, ideally, and once I'm a strong enough programmer, I would have anticipated this and written the following code from the get-go. But when you're learning, it's certainly reasonable to see an error. Oh, I didn't realize I should detect that, and then go back and improve your code. But of course, if you read the documentation, you ingrain some of the lessons learned from the past, you'll get into the habit of trying and checking for some of these exceptions yourself. So let me solve this in one possible way, as you proposed here. Let's try to handle this exception as follows. Let me go ahead now, and instead of just blindly calling this print line, let me try to print out, hello, my name is such and such, except if there is an issue, specifically an index error, then what do I want to go ahead and do? I'm going to say something like too few arguments. I could be more explanatory than that, but for now, I'm just going to explain to the user that they gave me too few arguments, too few words at the prompt. So now, it's still not going to work in quite the way I want. I'm still not going to be able to generate their name tag, but at least they're not going to see some cryptic error message and think that they themselves broke the program. Let me go ahead now and run python of name.py, enter, and too few arguments. OK, let me go ahead now and do python of name.py and type in my name, David, and now we're back in business. And I see that my name is on the screen too. But strictly speaking, I don't have to try to do this. I could actually be a little more defensive in writing this code. And maybe I could check whether or not the user has indeed provided a name or multiple names at the prompt so as to give them more refined error messages as well. So how might I do this? Well, let me go and undo the exception handling I've added. And why don't I instead more modestly try to do this? Let me go ahead and introduce a conditional here. If the length of sys.argv is less than 2, or equivalently equal to just one value, but I'll just stick with less than 2 for now, then go ahead and print out too few arguments. So I want ultimately 2 arguments. I want the name of the program at location 0, and I want the name of the human at location 1. So that's a total of 2 arguments. So if I have fewer than 2 arguments, let's tell the user with this print line, if the length of sys.argv is, say, greater than 2, like they typed in too many words at the prompt, well, let's tell them print, quote unquote, too many arguments. Else, if they did get it right and they gave me exactly 2 arguments, else, let's go ahead and print what I actually care about. All right, let me go down to my terminal window here and run python of name.py, and voila, a completely different type of error. This one, a syntax error, which we've seen in the past. Now, a syntax error, recall, is mea culpa, like I messed up here and I wrote invalid syntax, and so no amount of conditionals or exception handling is really going to catch this one. I need to go back and just get my program to work because it's not running at all. Well, let me go up here and see. Line 4 is the issue, and indeed, it looks like I have an unterminated string here. I need to go ahead and now add this double quote. So let me go ahead now, and with that red herring gone, let me rerun python of name.py and hit enter, and now we see too few arguments. OK, maybe it wants my full name. Let me go ahead now and run python of name.py, David Malin, typing in both words after the name of the file and hit enter. And now, of course, it's too many arguments. Fine, now I'll oblige and do python of name.py and just David. And there we have it, my name tag printed on the screen. So strictly speaking, we don't have to handle exceptions if we can be a little smarter about it and just check for the things that we're worried about, especially if we want to give the user more refined advice. We don't want to just tell them, no, something went wrong, or we don't want to pass. We want to tell them, no, that's too few. Or no, that's too many. We have conditionals in our vocabulary already via which we can now express that. Well, let me pause here and see if there's any questions now on how we handled the error before with the index error, or how now we're just proactively avoiding all index errors altogether by just checking first, is it too few, is it too many, or is it exactly what we want?
Hiya, thank you. So I was wondering, you touched upon kind of using your full name. Could we then, is there a way going forwards that perhaps we have people that want their full names and want just their first name, that we separate that into like, oh, this person has full name, this person has just the one name?
Absolutely, and allow me to propose we come back to that support for multiple names. But indeed, we could do that. And I should note, too, though, we can support full names right now if I do this. Instead of typing in David space Malin, which is problematic because, again, by definition of how argv works, each word ends up in a specific location in the list. But if I add quotes, single quotes or double quotes at the command line, now Python will view this as 2 total things, the name of the file and this full name. And now when I hit enter, I don't see the quotes. The whole thing is passed in as my full name. And if I want to adapt this further for multiple people, we'll be able to do that as well. Other questions now on this version with if, else, or on except before?
Hi, sir. I want to ask you, can we use multiple else statements?
Can you use multiple else's statements? No. Else is the last catch-all statement that you can have. You can have multiple if statements in the middle, but not multiple else's. All right. All right, well, let's turn our attention back now to this code and see if we can't refine it a bit more by adding in some additional functionality that we get with modules like the sys module. One of the things I don't love about this version of the code, even though arguably it is now correct, is that the essence of my program, which is just to print out the name tag, is kind of relegated to this else clause. And that's fine. Logically, it's correct. But generally speaking, there's something nice about keeping all of your error handling separate from the code that you really care about. Having all of these ifs, elifs, perhaps at the top of your code that are checking to make sure that all of the data is as expected. But then it would be nice, if only for design's sake, not to sort of hide in this else statement the actual code that you care about. I would prefer, for instance, to do something logically like this. I could check for errors up top, and then down here, print the name tags. It would be nice if those are sort of distinct blocks of code, all of which are here left aligned. But there's a problem with what I've just done here. Logically, what bug did I just introduce by getting rid of the else and introducing line 10 on its own with no indentation outside of the conditional? What bug have I just introduced? What mistake, to be clear?
Name error.
Ironically, it's a name error, but not a name error exception. It's an error with my name, but I think you're frozen for me. It's going to raise an exception because even though I'm checking the length of sys.argv up top, and even though I'm checking it again for being greater than 2, not just less than 2, but greater, I'm still then blindly and incorrectly assuming it's now going to exist. So just to be clear, if I run python of name.py and I don't type any arguments, I've got too few, I think I'm going to see that I have too few, but I'm also going to see that same exception. At the very top of my terminal Windows output, there's my error message, too few arguments. But again, on line 10, I blindly proceed to still index into my list at location 1, which does not exist. So it turns out there's a better way to handle errors like this, especially if you're writing a program in Python that's just meant to run briefly and then exit anyway. But maybe we could start to exit prematurely if the program itself just can't proceed. If the user has not given us the data we want, perhaps we should just exit the program earlier than we might otherwise. So let me go ahead and do this. Let me go ahead and remove my comments so as to focus only on the code here. And let me propose that instead of just printing quote unquote too few arguments, I'm going to use one other function that comes with the sys module. I'm going to go ahead and call sys.exit. And as the name suggests, it's going to do exactly that. With the system's help, it's going to exit my program then and there on line 4. Why is that OK? Well, if you gave me too few arguments, I have nothing more to say to you, the user. I might as well exit a bit prematurely. And I can do this as well on line 6. Let's go ahead and not just print that, but sys.exit, quote unquote, too many arguments. Print out that message and just exit right there. Now I can trust that by the time I get to line 8, every error condition has been checked for, and so it's safe for me to assume that there is, in fact, an item at location 1 in sys.argv. So let me go ahead now and run this. Python of name.py, enter, too few arguments. But I'm back at my prompt. Nothing more has happened. Let me run it again. Python of name.py, David Malin with no quotes, enter. Too many arguments is now printed here. Finally, Python of name.py, just David, enter. Hello, my name is David. So we have then in sys 2 forms of functionality now. We have access to this variable, sys.argv, this argument vector that gives me all of the words that were typed at the prompt, including the program's own file name. And it turns out, if we read further in the documentation, there's an exit function that can take different types of inputs, but if I pass it a string like this, it will indeed print that string for me and then exit from my program then and there. Questions now on exiting from programs like this. To be clear, all of this time, once Python gets to the bottom of your file, it's going to exit anyway. So I'm using sys.exit now just to make sure that I exit earlier than otherwise.
My question is about the sys.argv. So is that capable of accepting or taking multiple elements at once? Let's say, for example, Python name.py, David Malin, I'm a male, 20 years old. And if, let's say, I only want to access your name, which is at the first index, and then your age is, say, at the 6th index, can I say sys.rv1 and another one for 6 to access what I just want? Is that possible for sys.rv?
Short answer, yes, I think, if I understand your question correctly, whereby you're proposing to have many words at the end of the command and you want to access those individual words. Absolutely. At some point, it gets a little fragile, I would say, if you're typing so many words at the prompt that the order really matters. And so it turns out there's a lot of programs, and there's functionality in Python that can allow you to provide those values, like name or age or any number of other fields, in any order you want, but pass in a bit more information textually that tells the program how you want to use it. So in short, what you're describing is possible. And let me do a small incarnation of it as follows. Let me propose that we go back to my code here, and let's propose that we actually now want to support multiple values at the prompt. So there's going to be no such thing as too many arguments. Suppose that I want to generate name tags, not just for David, but for David, for Carter, for Rongshin, for others in the group who all want their name tags as well. So I'm going to go ahead and do this. I'm going to get rid of my elif condition because I don't want to limit the maximum number of words that are typed at the prompt anymore. I instead want to iterate over every name at the prompt. So I'm going to say this. For arg in sys.argv, go ahead and print out, this time, arg. So what am I doing here? Well, even though the syntax is a little different, the idea is the same as before when we've had loops. I'm using a for loop to iterate over a list. The list in question here is sys.argv. Arg is a variable that I'm creating on the fly. The for loop is going to make sure that the first time through this loop, arg is set to the first word on the command line. The second time through the loop, Python's going to make sure that arg is now set to the second thing on the command line, and so forth. That's just how a for loop works. It updates the variable for us. I don't have to call it arg. I could call it name, so long as I change it to name in both places. But arg is reasonable if I'm iterating over arguments more generally. If I now run this program, though, unfortunately, there's a little bit of a bug. Even if I type in David and Carter and Rongshin, I'm not going to get just 3 name tags. In your mind, does anyone see the bug I'm about to trip over? It's not a huge deal if I've got enough name tags to go around, but I'm going to be wasting one because this is going to print not 3, but 4 name tags, whereby the first contains the name of the program itself. Maybe not a big deal. Maybe that's the sticker we don't bother handing out, but it's wasteful, and it does look wrong. So how could we get access to not all 4 elements of argv, but just a slice of argv? And this is actually a technical term. In Python and some other languages, to take a slice of a list means to take a subset of it. Maybe from the beginning, maybe the middle, maybe the end. But a slice is a subset of a data structure like a list. Well, how do I actually do this in code? Well, in Python, it's actually very easy to take a slice of a list, that is a subset thereof. You can simply do this. At the end of the list name, sys.argv in this case, you can use square brackets. And then in those square brackets, you can specify the start and the end of the list that you want to retain. I want to start at element 1, not 0. I want to start at element 1, and I want to just go to the end. So I'm actually going to omit a second number altogether. It's not necessary to have a second number, but I do need that colon because this is going to give me a slice of the list. It's going to give me a slice of the list that starts at location 1, not 0, and the colon and then a blank just means it's going to give me everything else. So this is equivalently going to slice off the first element of the list and give me a new list that contains just those 3 human names, not the name of the file itself. Let me try running this again. I'm going to run Python of name.py, David, Carter, Rongshin. This time, hopefully, I'm going to get 3 and only 3 name tags. Hitting enter, and indeed, I've done now just this. So again, using some relatively simple syntax in Python, we can use square brackets not just to go to specific elements like bracket 0 or bracket 1. We can also get subsets of the list, slices of the list, by doing bracket something colon something, where each of those somethings is a number, the beginning or the end, and they're optional, depending on whether you want all of them or just some. Any questions now on this version, which adds the loop and these slices with that new syntax?
Can we slice starting from the end of the argument vector?
You can. You can slice something from the end of the argument vector, and this might blow one's mind a little bit. Let me go ahead and do this. Let's see. Let me go ahead and do -1 at the end, using a negative number here and running the same command. We've just uninvited Rongshin from receiving a name tag here. So if you use a negative number, it has the effect of counting to the in the other direction from the end of the list. A good question there. Other questions now on slices, on looping over sys.argv.
Hi. So I remember very early on when we were talking about only having 2 decimal places in float value. Does this is that in the same vein? Like because we use the colon point to f. So is that the same thing then? Why would the f be included then in the point to f as opposed to here when you just have the numbers?
A really good question, and it's just the short answer is that context matters. So there's only so many keys on our keyboard, and so we sometimes use the same symbols for different things. So what you're alluding to is the format code in F-string for actually formatting a number, using a colon, using a period, using a number, using the letter F, and so forth. And that is very specific to the F-string feature of Python. This case has nothing to do with any of that syntax per se. This is just using a colon in a different context to solve this problem, to implement a slice. The authors of Python could have chosen another symbol, but honestly, looking down at my keyboard here, we don't have that many to choose from that are easy to type, so sometimes they have different meanings. A good question as well. Allow me to propose now that we take things further and move away from using only those modules, those libraries that Python comes with, to talk about more generally packages that exist. One of the reasons that Python is so popular and powerful these days is that there's a lot of third-party libraries out there as well, otherwise known as packages. Strictly speaking, Python itself has a term of art called a package, which is a module, essentially, that's implemented in a folder. Not just a file, but a folder. But more generally, a package is a third-party library that I can install on our own Mac or PC or our cloud server and gain access to even more functionality that other people have implemented for us. Now, one of the locations you can get all of these packages is called the PyPI website, the Python Package Index, which lives at this URL here. And this is a website that is searchable via the command line as well as via the web that allows you to download and install all sorts of packages. Even CS50 has some of its own packages in services like these. Now, there's a fun one out there that's a throwback to a command that's been around for years in command line environments called cow_say. Cow_say is a package in Python that allows you to have a cow say something on your screen. If curious to read up on it, its own documentation is on pypi.org, specifically at this URL here. But how do you actually get the package into your system? Well, technically, you could figure out how to download the file and maybe unzip it and put it into the right location on your Mac or PC. But nowadays, a lot of languages, Python among them, has what's called its own package manager. This one here called pip, which is just one. So pip is a program that generally comes with Python itself nowadays that allows you to install packages onto your own Macs or PCs or cloud environment by just running a command. And then voila, you have access to a whole new library in Python that didn't come with Python itself, but now it's available on your system for you. Let's go back to VS Code here. And in my terminal window, I'm going to go ahead and type pip install cow_say. Now, what's going on here? Pip is the command, the package manager, and I want to install what package? The package called cow_say. I'm going to go ahead and hit enter here, and after a little bit of output, it has successfully installed cow_say. Now, what does that mean? That means I can now go about importing this into my own code. Well, let's go ahead and see what this means. Let me go ahead and create a new file with code called say.py, because I want something to be said on the screen. And in my new tab here, I'm going to go ahead and import cow_say, which presumably is now installed. I'm now going to import sys as well, because I'd like to use some command line arguments in this program just so that I can run it quickly. And without using the input function, I can get the user's name immediately from the prompt. And let me go ahead and do this. I'm going to do a bit of error checking proactively this time. And rather than use less than or greater than, I'm this time going to say if the length of sys.argv does equal 2. So if the human is provided just the name of the program and their own first name, we're good to go. I'm going to do the following. I'm going to call a function called cow in the package called cow_say, and I'm going to pass in a string, hello, comma, and then, as in the past, I'm going to pass in just one string, because according to its documentation, it's not like print. I can't pass in comma this, comma that. I can only pass in one string, so I'm going to concatenate the contents of sys.argv bracket 1. So long as then I type in my name, David, after the name of this program, it should end up in sys.argv1, in which case this line 5 of code should concatenate hello with my name, with a space in between, and apparently a cow is going to say it. So let's see what happens here. Let me go ahead and clear my screen and increase the size of my terminal window. Let me go ahead and run python of say.py and type my name, David, and enter. There is the program called cowsay. It literally has a cow say something on the screen. And this is a throwback to a program from yesteryear that tended to come with a lot of systems. This is otherwise known as ASCII art. It's a textual way using just keys on your keyboard to print pictures of sorts on the screen. Now, we can really go down the rabbit hole here, and there's questionable academic value of doing so, so I'll do so just once. Turns out the cowsay package comes with other functions as well. One of those functions, for instance, is trex. And if I now increase the size of my terminal window, we'll perhaps see where we're going with this. Let me now run again python of say.py. This time, let me not provide my name just to see if it's broken. It's still OK, because we have that if condition. If the length of sys.argv equals 2, and only if it equals 2 do we do anything. That's why we're not seeing anything here. Let me go ahead and cooperate now. Say.py space David. And it's no longer a cow, but if I zoom out on my screen, a T-Rex. Why? Just because. These are the things you can do once you know how to program. You can even package them up and make them freely available to others as open source software. For us, it's demonstrative of a feature more generally here, namely being able to install these third-party packages and how you might do so in Python. Now, I'll leave this up on the screen for a moment and see if there's any questions about cows or Tyrannosaurus rexes or packages more generally. I'm really qualified to speak to just one of those.
Hi, I've got 2 questions. It's a bit earlier than what's supposed to be. So the first question is, the packages that you're calling to use in the program, are they the same as, let's say, because I'm doing Java, the same as calling a class of a Java file in order to use its functions? And my second question is, what's the actual purpose of using command line arguments as you use? Because it's not really the best way to, as you say, be user friendly, where as in, let's say the person who's using the program doesn't know what they want, what the program's asking them.
Really good questions. The first question about the comparison with Java. Python packages are similar to Java packages, where you have something dot something dot something at the top of your program that gives you access to a class or something else. Python itself supports classes, more on those down the road, and you can do very similar things in Python as you can do with Java. But the analog really is Python packages to Java packages here. As for command line arguments, you ask a good question. Why do we use them, especially if they're a little less user-friendly? They're a little less user-friendly to people who aren't in this Zoom, to be honest. You and I, as we learn more and more about programming and more about command line arguments, I dare say will become more comfortable with and tend to prefer the ability to customize commands using these command line arguments. Why? Productivity. It tends to make you faster because you get into the habit of knowing exactly how you can configure your software without having to manually answer questions. And case in point, all of this time have we been running python of something.py. You could imagine not doing that. You could imagine typing only Python, hitting enter, and then you're prompted for the name of the file you want to run. So you type in something.py, and then it runs. Not a big deal, but I would argue that over time, you're going to get a little tired of that tedium, and you would much prefer to just automate the command again and again and again, especially with little conveniences like being able to hit up and down in your keyboard history so as to rerun those same commands. Automation is big too. If you emerge from a class like this and start using Python to automate processes at work or for personal projects or the like, the ability to specify all of your inputs on the one line just means you can get work done more quickly. So hands down, absolutely, using command line arguments is a more arcane feature of systems that most of us are no longer as familiar with because of Windows and Mac OS and other operating systems that have buttons and GUIs and menus. But the more comfortable you get with programming, I dare say the more you will tend to prefer these capabilities because they allow you to do things more quickly. With that said, allow me to propose that we take a turn toward yet another package that's particularly popular and just as easy to install, all toward an end of using APIs. Now, APIs are not something that's Python specific. More generally, an API is an application programming interface, and it can refer to Python files and functions, but often APIs really refer to third-party services that you and I can write code that talk to. Many APIs, but not all, live on the internet these days, so that so long as you have a browser or so long as you have some experience with Python programming or programming in any language, you can write code that in effect pretends to be a browser, connects to that third-party API on a server, and download some data that you can then incorporate into your own program. Now, how do you do this? Well, Python has a very popular package that you can install via pip called requests. The requests library allows you to make web requests, internet requests, using Python code, essentially as though you were a browser yourself. You can automate, therefore, the retrieval of URLs that start with HTTP or HTTPS. The documentation for this library is that a URL like this, but it too can be installed at the command line. And even though it's third party, it's one of the most popular and commonly used packages out there in Python. And this too is one of the reasons, again, that Python is so popular. There's just so many solutions to problems that you and I have or are invariably going to have when we write projects of our own. There's just a really vibrant ecosystem, a really vibrant community of open source software that's that easy for us to install. Let me go back to my terminal window now and run pip install requests in order to install this package on my own system. And after some lines of output, I'll see that it's successfully installed. Now let's go ahead and create a new file here. For instance, iTunes.py. It turns out that Apple has its own API for their iTunes service, the software that provides you with the ability to download and search for music and songs and other information as well. And it turns out that, let me go back over to my computer here and open up a browser like Chrome. And let me go ahead and visit this URL here, https://itunes.apple.com/search, !entity equals song, ampersand, limit equals 1, ampersand, term equals Weezer. Now, I constructed this URL manually by reading the documentation for Apple's API, Application Programming Interface for iTunes. And what they told me is that if I want to search for information about songs in their database, I should specify entity equals song, so that it's songs and not albums or artists or something like that. If I just want to get back information on one song, I'm going to provide limit equals 1. And if the band I want to search for, the artist, is Weezer, I should specify term equals Weezer. So with this, if I go ahead and hit enter and visit this URL, I actually end up with a text file in my downloads folder on my Mac. If I go ahead and open that text file that my browser just downloaded, we'll see all of this text here, which at first glance might look a bit cryptic, but it actually follows a pattern. Notice this curly brace at the start, and notice this closed curly brace at the end. Notice this open square bracket here, and notice this closed square bracket here. And in between those pieces of syntax are a whole bunch of strings and values. In fact, a whole bunch of key value pairs. What we're looking at here is a standard text format known as JSON, JavaScript Object Notation, which, yes, is technically related to yet another programming language called JavaScript, but JSON itself is typically used nowadays as a language agnostic format for exchanging data between computers. By language agnostic, I mean you don't have to use JavaScript. You can use Python or any other language to read JSON or write it as well. And it's a completely text-based format, which means that if I visit that URL with my browser, what gets downloaded is just a bunch of text, but that text is formatted in a standard way using curly braces and square brackets, using quotes and some colons that ultimately contains all of the information in Apple's database on Weezer's song, at least the first one, because I limited it to one, in their database. And that's an API, an application programming interface, a mechanism whereby I can access data on someone else's server and somehow integrate it into my own program. Now, of course, my browser, Chrome, is not something I wrote. I should actually write some Python code that perhaps pretends to be a browser to grab this same data. So let's do that. Let me go back to VS Code here, and let me write a program with code itunes.py. And we're going to write some code via which I can then use the iTunes API and in turn Python to get information about any band that I might want. I'm going to go here and import first the requests library, which I installed earlier in order to make those HTTP requests. I'm going to go ahead and import the sys library, via which I'll have the ability to use command line arguments like specification of the band that I want to search for, if not Weezer. And then down here, I'm going to go ahead and insert some error checking to say if the length of sys.argv does not equal 2, so if the user does not provide me with the name of the file they want to run and the name of a band, and that's it, you know what, let's just go ahead and